Hello everyone. In the last video we discussed about units and dimensions basic theory and some examples. In this video I'll discuss about frequently asked models in units and dimensions. If you are a new subscriber, first go through the video on theory and then come to this so that you will have a better understanding. Let's check the examples now. The first example is like this. The force between two atoms is given by F is equal to alpha beta into e power of minus x by alpha kt, where x is the distance, k is the Boltzmann constant, T is the temperature, alpha and beta are constants. Find the dimensional formula for those constants. Look at this. First I will take that exponent term e power of minus x by alpha kt. Whenever there is an exponent term in this power, whatever term it is having, it will not have any dimensions. That means x by alpha kt is a dimensionless quantity, m power 0, l power 0, t power 0. This is possible when dimensions of x is equal to dimensions of alpha kt. So dimensions of alpha will be equal to dimensions of x by dimensions of kt. So from equipartition theorem, the energy in each degree of freedom for any gas molecule is half kt. So kt will have same dimensions as that of energy. What are dimensions of energy? That will be m l square t power of minus 2. And x is given as distance, so that x is L and kt is m L square t power of minus 2. So that this will be m power of minus 1 L power of minus 1 t power of 2. This is corresponding dimensions for alpha. Now look at this. This term is in exponent which will not have any dimensions. Now f is equal to alpha into beta. So whatever dimensions f will have, alpha into beta must also have the same dimensions. So beta dimensions are nothing but force dimensions by alpha dimensions. Force dimensions are m l t power of minus 2 by alpha dimensions are m power of minus 1 l power of minus 1 t square. So that this will be equal to m square l square t power of minus 4. So that is the corresponding dimensions for beta and this is dimensions for alpha. Let's check the next question. L, R, C and V represent inductance, resistance, capacitance and voltage respectively. Then dimensions of L by R, C, V will be, there is an inductor and if there is a resistor, this is called as LR circuit. In LR circuit, time constant is given as R by L. So this implies L by R will have dimensions of 1 by time, that will be t power of minus 1. Similarly, if there is any capacitor of capacitance C that is connected to an external source, on one plate it will have positive charge and on other plate it will have negative charge for this capacitor, and if the applied voltage is V, then the charge on the plates of the capacitor Q will be equal to C into V. So that C into V will have dimensions of ampere into time, because charge is nothing but I into T, because I is defined as charge per unit time. So Q will be equal to I into T, so that I will have units of ampere and time will have units of time, so that this will be equal to ampere into time. Now we are asked for dimensions of L by R into CV. So L by R is nothing but t power of minus 1 and Cv is in the denominator, that is q in the denominator, that will be a into t, so that this will be equal to a power of minus 1 and t power of minus 2. That is the corresponding dimensions for L by RCV. Now look at this. The dimensions of square root of epsilon naught by mu naught is, here epsilon naught is permittivity of free space and mu naught is permeability of free space. You are given an equation like this: square root of epsilon naught by mu naught, or this will be equal to, I can write like this, square root of numerator and denominator I will multiply with epsilon naught, so this will be epsilon naught mu naught, so that this becomes epsilon naught by square root of mu naught into epsilon naught. 1 by square root of mu naught into epsilon naught is nothing but velocity of light, so that the same equation I can write like this, epsilon naught into c. So I know the dimensions of c. Dimensions of c will be equal to L t power of minus 1, because it is velocity, light velocity. Here c is light velocity. Now I have to identify dimensions of epsilon naught. For that I will take help of Coulomb's law, that is 1 by 4 pi epsilon naught q1 q2 by r square. So epsilon naught will have dimensions of, I can neglect this 1 by 4 pi which is a constant, that will be q1 q2 by f r square. q1 will have dimensions of ampere into time whole square by force is m l t power of minus 2 into l square, distance square, so that this will be m power of minus 1 L into L square, that is L cube, so that L power of minus 3, t power of minus 2 and t square, and the numerator it will be t power of 4 into ampere square. This is the corresponding dimensions for epsilon naught. If I substitute that over here, epsilon naught is m power of minus 1, L power of minus 3 into t power of 4 into ampere square, velocity of light, that will be L t power of minus 1, so that this will be m power of minus 1, L power of minus 2, t cube into a square. This is corresponding dimensions for square root of epsilon naught by mu naught. The next example will be like this: if the surface tension, moment of inertia and Planck's constant were to be taken as fundamental units, the dimensional formula for linear momentum will be, we are asked to express linear momentum in terms of surface tension, moment of inertia and Planck's constant. For that you have to write the dimensions of each and every physical quantity involved. So momentum, that will be m mass into velocity, so that will be m L t power of minus 1, and surface tension is nothing but force per unit length, that will be m L t power of minus 2 by L, so that this will be m t power of minus 2, and moment of inertia, that is m k square, mass into square of radius of gyration. Square of radius of gyration is nothing but it is the distance, so that m L power of 2, and similarly Planck's constant, that is equal to mvr, that means Planck's constant and angular momentum will have same dimensions, and this will be equal to m and L t power of minus 1, and then 1 L will be there, so L square t power of minus 1. So if I substitute all these values by taking this proportionality constant as 1, this will become like this: m L t power of minus 1 is equal to m t power of minus 2 whole power of x, m L square whole power of y and m L square t power of minus 1 whole power of z. So on our left hand side we are having m L t power of minus 1. Here add all m powers. For m powers I am having here it is x, here it is y, and here it is z. So that m power of x plus y plus z. And next is L power of 2y plus 2z, 2y plus 2z, and t power of, here it is minus 2x and minus z, so minus 2x minus z. Now from our left hand side and right hand side, since bases are same, I will equate their powers. So if I equate their powers, for m powers that will be x plus y plus z is equal to 1. And similarly for the powers of L, let this be equation 1. Now for powers of L, that is 2y plus 2z is equal to 1. That implies y plus z is equal to half. Let this be second one. And the third one is powers of time, that will be minus 2x minus z is equal to minus 1, or 2x plus z is equal to 1. Let this be equation 3. Now I will substitute equation 2 in equation 1. So equation 1 implies x plus y plus z is 1 by 2 is equal to 1. That implies x will be equal to half. 1 minus half, it will be half. Now I will substitute this in equation 3. So from equation 3, it will be 2 into 1 by 2 plus z is equal to 1. So z will be equal to 0. And now I will substitute this z in equation 2. So y plus 0 is equal to half. That implies y will be equal to half. Now the momentum can be expressed as surface tension power x, so s power of half, moment of inertia per y, that is also y power of half, and Planck's constant power z, so h power of 0. So this is the corresponding dimensional formula for momentum in terms of the given quantities. Now let's check the next question. There is a quantity x is given by epsilon naught L into delta V by delta T. You are given like this: x is equal to epsilon naught L into delta V by delta T. Here you are given that L is length, delta V is potential difference, and delta T is time, and epsilon naught is permittivity of free space. And just now we discussed this epsilon naught, you can identify epsilon naught dimensional formula from q1 q2 by f r square. So what is q1 q2? That is a square t square by m L t power of minus 2 into L square, or this will be m power of minus 1 L power of minus 3 and t power of 4 into a square. This is corresponding dimensional formula for epsilon naught. And potential difference is nothing but work done per unit charge. Work will have dimensions of m L square t power of minus 2 by charge is ampere into time. So that this will be m L square t power of minus 3 into a power of minus 1. So that is for potential. And of course you all know about for length it is L, and for time it is T. Substitute all these dimensional analysis formulae in this. For first epsilon naught it is m power of minus 1 L power of minus 3 t power of 4 a square into L is L into delta V, that is m L square T power of minus 3 into ampere power of minus 1 by time will have dimensions of time. So if this comes to numerator, T power of minus 3, T power of minus 4 and there is T power of 4. So this gets cancelled and this is L power of minus 3, L into L square, L cube. So that L power of minus 3 gets cancelled, M gets cancelled. We'll have A square into A power of minus 1. That is nothing but A. So that X represents current. X represents current. So that the next question will be like this. To find the distance over a signal over which a signal can be seen clearly in foggy conditions, a railway engineer uses dimensional analysis and assumes that the distance depends on mass density of the fog, intensity of light from the signal and its frequency. The engineer finds that D is proportional to S power of 1 by N, where S is known as intensity. We are asked to find the value of that N. So D depends on, distance depends on mass density, so that is density power of X, and intensity power of Y, and frequency power of Z. Intensity of light from the signal and its frequency. So now you have to write dimensional formula for all these. Of course you all know distance is nothing but it will have dimensions of length, and density is nothing but mass by volume, so that it will have dimensions of ml power of minus 3, and intensity is nothing but power per unit area. Power, if you don't know, work done by time taken by area. Work done will be ml square T power of minus 2 by T, so that this will be T power of minus 3 by area. So L square gets cancelled. You will have m T power of minus 3. This is for intensity. And similarly for frequency, that is reciprocal of time period, so that it will have dimensions of T power of minus 1. Now by assuming the proportionality constant as 1, D, its dimensions are m power of L power of m into L power of minus 3 whole power of X, intensity m into T power of minus 3 whole power of Y, and T power of minus 1 whole power of Z. Now this distance, it will have dimensions of length. So m power of, here I am having X, here I am having Y, so that this will be X plus Y, and L power of minus 3X, L power of minus 3X, and T power of minus 3Y minus Z. So if I equate the powers, m power will be equal to 0 on our left hand side. So if I am equating powers of m, so that X plus Y will be equal to 0. And moreover from this, I can write like this, Y will be equal to minus X. So if I go with powers of L, minus 3X is equal to 1. So X will be equal to minus 1 by 3. If X is minus 1 by 3, definitely Y will be plus 1 by 3, because Y is equal to minus X. Now this Y is involved in our intensity, that is the question what you ask. So S power of Y is nothing but S power of 1 by 3. So this can be written as S power of 1 by N. So N will be equal to 3. So this is your corresponding answer. Now look at this next question. There is turpentine oil flowing through a tube of length L and radius R. The pressure difference between two ends of the tube is P. So the viscosity of oil is given by eta is equal to P into R square minus X square by 4VL, where V is the velocity of the oil and X is the axis of the tube, that is the velocity measured at a distance x from the axis of the tube. You are asked to identify the dimensional formula for viscosity. Now look at this. From this equation, if we are having a quantity like this, whatever dimensions, this will have this will also must have the same dimensions, and this total quantity must also have the same dimensions. So r square minus x square will have dimensions of L square, and pressure is nothing but force per unit area, that will be m L T power of minus 2 by L square, that will be m L power of minus 1 T power of minus 2. And for velocity, that will be L T power of minus 1, and of course for length it is L. Now I will substitute all these dimensional formulas in this equation. P into r square minus x square by 4VL. What is dimensional formula for P? That is m L power of minus 1 T power of minus 2 into r square minus x square, that is L square, by 4 into V, that is L T power of minus 1. 4 will not have any dimensions, so need not to write that 4, into L. Now from this, L into L, this is L square, so L square gets cancelled, and T power of minus 1 on T power of minus 1 gets cancelled. You left with m L power of minus 1 T power of minus 1. So this is the corresponding dimensional formula for coefficient of viscosity. The displacement of a progressive wave is represented by an equation like this, where x is the distance and t is the time, then the dimensions of omega by k. Now look at this, whenever there is a sine function or any trigonometric function, omega t minus kx, the function within this will not have any dimensions. So omega t is dimensionless and kx is also dimensionless, and both must have same dimensions. Then only I can subtract one number from the other. So that if omega t is equal to kx, you are asked for omega by k. So omega by k will be equal to x by t, where x is given as length and t is time. So that this will be L T power of minus 1. So omega by k represents a quantity called velocity. This is an important point, you can remember like this. Whenever you are given a progressive wave, coefficient of t by coefficient of x, omega is coefficient of t and k is coefficient of x, that gives velocity. Just remember this, that will be helpful for you. The next one is like this: using the principle of homogeneity of dimensions, which of the following equation is correct? So first you have to write the dimensional formula for all the quantities involved, and then you can solve each and every equation which is correct. The left hand side dimensions must be equal to right hand side dimensions. Here you are having universal gravitational constant that is involved in this equation, that is gravitational force between two masses m1 and m2 is given as F is equal to g m1 m2 by r square. So g will be equal to F r square by m1 m2. F will have dimensions of m L T power of minus 2 into r square, that is L square, by m square. So that this will be m power of minus 1 L cube and t power of minus 2. This is the corresponding dimensions for g. And of course here mass is involved. Mass will have dimensions of m, and radius is involved. So radius is nothing but length. Its dimensions are L. Now look at this first option. In this first option, on our right hand side, the dimensions are for time t, t square. On our left hand side is t square, and right hand side you are having r cube by gm. Forget about that 4 pi square, it will not have any dimensions. What is r cube? R cube is nothing but L cube by gm. What is g? M power of minus 1 L cube t power of minus 2 into m. M will have dimensions of m, so that m gets cancelled, L cube gets cancelled, 1 by t power of minus 2 that is t square. So our left hand side is equal to right hand side, so that our correct option is A. And similarly check the other options. In this only length is involved, so this is not right. In this mass is not there, but in denominator I will have g, in which m power minus 1 is there, so that will be involved, so that this can be cancelled. And here also mass is involved and time is not involved anywhere, so that this equation is wrong. That is how you can check whether a given equation is dimensionally correct or not. Now look at this. There is a new system of units is proposed in which units of mass is alpha kg and unit of length is beta meters and units of time is gamma seconds. What will be the value of 5 joules in that new system? For this, joules is the unit of energy. For that, the dimensional formula will be m L square t power of minus 2. Now you all know this. I can convert one system of units to another system of units, so that n2 will be equal to n1 into m1 by m2 whole power of a into L1 by L2 whole power of b into T1 by T2 whole power of c. N1 is given as 5 joules. M1 in first system, that is our known system, it is kg, and unknown system it is given as alpha kg whole power of a. Here a is nothing but 1, b is nothing but 2, c is nothing but minus 2. So here a is 1, L1 that is meter by beta meters whole square, and this is second by gamma second whole power of minus 2. So kg gets cancelled, meter gets cancelled, and second gets cancelled. You left with 5 into 1 by alpha beta square into 1 by gamma power minus 2, or this can be written as 5 into gamma square by alpha beta square. So that is how you can solve these type of questions, that is conversion of one system to another system. Now we are given a list. You have to match the dimensional formula with the corresponding physical quantities. Now choose whichever easy for you. For me, option B, that is energy, which is easy. Energy will have dimensions like this: m L square t power of minus 2. And similarly for linear momentum, it is mass into velocity, so m L t power of minus 1. And then for Planck's constant, that is of angular momentum, that will be m L square t power of minus 1. And similarly for electric potential is nothing but work done per unit charge. This will be m L square t power of minus 2 by ampere into time, or this will be equal to m L square t power of minus 3 into ampere per minus 1, or it is given as I, so that I can represent in 1. So first look at this A, Planck's constant m L square t power of minus 1, so that this is A. And then look at B, m L square t power of minus 2, so that this will be B. And next look at C, that is electric potential m L square t power of minus 3 I power of minus 1, so that this will be electric potential. And linear momentum, of course this will be our linear momentum. That is how you can identify dimensional formulas for different physical quantities, and you can match them. The next question is like this: if E is the electric charge, C is the speed of light in free space, and H is Planck's constant, then the quantity 1 by 4 pi epsilon naught E square by hc has dimensions of. See, for this I'll take help of Coulomb's law. F is equal to 1 by 4 pi epsilon naught q1 q2 by r square. If both the charges are having same magnitude, this can be written as 1 by 4 pi epsilon naught E square by r square. Now look at this, you are having 1 by 4 pi epsilon naught E square, so that 1 by 4 pi epsilon naught E square is nothing but f into r square, and f, it will have dimensions of m l t power of minus 2 into r square, that is l square. So that this will be m l cube t power of minus 2. That is dimensional formula for 1 by 4 pi epsilon naught e square, ml t power of minus 2 into l square. Similarly, Planck's constant, that is m l square t power of minus 1, and similarly for velocity of light, that will be l t power of minus 1. Now I'll go with this physical quantity. Assume that as x is equal to e square by 4 pi epsilon naught into 1 by h into c. So what is dimensional formula for e square by 4 pi epsilon naught? That is m l cube t power of minus 2 by h into c. What is h? M l square t power of minus 1 into l t power of minus 1. So t power of minus 1, t power of minus 1, t power of minus 2 gets cancelled. L square, L cube gets cancelled. M gets cancelled. So this will be m power of 0, L power of 0, t power of 0, which is a dimensionless quantity. The next questions, so that we are completing all those questions. Now just check the theory first if you are a new subscriber, and if you are already gone through that video, just check each and every example, pause the video and look at each and every example. A detailed explanation is given. So subscribe profile and press bell icon for further notifications. Have a great time.